Alright, this section is on parallelograms. And after this, we're just going to call them a p-gram, because I don't want to keep writing out parallelo. Okay? In order for a quadrilateral to be classified somebody needs to turn her phone off as a p-gram, it must pass one of the four tests. And let's see test number 1. Both pairs of opposite sides congruent. Test 2. Both pairs of opposite angles congruent. Test 3. Diagonals bisect each other. Diagonals bisect each other. Let's draw a picture of that to make sure you're real clear on it. So we gotta just put a quadrilateral on your paper. Label it ABCD. Then connect D to B and connect A to C. D to B is a diagonal, and let's make point E right in the middle. So if DE is congruent to EB and AE is congruent to EC, then the diagonals bisect each other. They split each other in half. And when the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And the fourth test, one pair of opposite sides are parallel and congruent. Just one pair. So again, one pair of opposite sides. Side AB is opposite of side DC. and side AD is opposite of side BC. So if AB is parallel to DC and congruent, then the shape is a parallelogram. So if the shape's got 4 sides and it meets any of those 4 criteria, or it passes any of those 4 tests, then it's a parallelogram. Got it? Alright, so turn the page. Look at example 1 on page 414. The question is, determine whether the quadrilateral is a parallelogram. And I believe it asks you to justify your answer. So if you're given that shape there, FGHJ, F to G is 14, J to H is 14, angle G is 100, and angle H is 80. And they kind of come right at you with the first example being a pretty tough one, as far as I'm concerned. Is this quadrilateral parallelogram? Alright, you don't know anything about both pairs of opposite sides, so you can't use that test. You don't know anything about both pairs of opposite angles. You don't know anything about diagonals, right? So by process of elimination, the only test you can use, one pair of opposite sides, parallel and congruent. Well, F to G is congruent to J to H. But are they parallel to each other? Okay? There's nothing in the problem that says that they're parallel other than the fact that if you extend FG to the right and you extend JH to the right, and then if you take GH and you extend it up and down, you end up with 2 lines cut by a transversal. And that 100-degree angle and that 80-degree angle, those are called same side interiors. And when we covered parallel lines and transversals, there was a rule that said if same side interiors are supplementary, then the lines are parallel. So because of that rule, FG is parallel to JH. So your answer in this case would be yes. FG and JH are both parallel and congruent. Do you see example 1A? Is that a quadrilateral? Or I'm sorry, is that a parallelogram? Pretty much a quick glance determines that it's a parallelogram. By which rule? Yeah, the first rule, right? Aren't both pairs of opposite sides congruent? So yes, both pairs of opposite sides are congruent. Example 1B. You've got an 85-degree angle and another 85-degree angle. and a pair of opposite sides that are congruent.
Question about the.
Not round. You have to come back. In this case, and if you just use the process of elimination on your rules or go through the rules, are both pairs of opposite sides congruent? Not enough information. Are opposite angles congruent? Both pairs of opposite angles. Well, the two 85s are congruent, but you don't know anything about angle A and angle B here. Diagonals bisect each other. There are no diagonals, so you don't know if they bisect each other. One pair of opposite sides of a quadrilateral is both parallel and congruent. Well, you got a pair of opposite sides that are congruent, but there's not enough information in the problem to determine if they're parallel to each other. So you're going to say no. And you can just say it does not pass any test. It didn't pass any of the 4 tests. Any questions on any of those examples in example 1? Alright, look over at 3 on the next page, on page 415. And now you've got another quadrilateral. FGHJ. Point K is where the diagonals meet. And you're told that F to K is 3x minus 1. K to G, 4y plus 3. J to K, 6y minus 2. K to H is 2x plus 3. And you are asked to find x and y. So that the quadrilateral is a parallelogram. Well, you're dealing with diagonals. And when diagonals bisect each other in a quadrilateral, then the quadrilateral is a parallelogram. So that allows you to set your expressions 3x minus 1 equal to your 2x plus 3 and your 6y minus 2 equal to your 4y plus 3. And if you solve for the x and y, then those expressions would be equal to each other, and those would be the values of x and y that would make that a parallelogram. So let's start with the x and subtract 2x from each side, and then add 1 to each side. So your x value would be equal to 4, and solve for your y. So those are your x and y values when that shape is a parallelogram. Does everybody get the idea of what's going on? If you look at the next example there, if you had to solve for x and y again in this problem so that the shape is a parallelogram, in this case, you're dealing with opposite angles. So you would set your 7x equal to 56 and solve for x. and you would set your 4y plus 4 equal to 5y minus 26. Solve for y. On problem 3b, you're dealing with opposite sides, so you would make your 4y minus 9 equal to your 2y plus 5, and your 3x plus 4 equal to your 3x plus 4 equal to the 5x minus 2, and solve for x. Everybody understand what's going on? Okay, make your quadrilateral meet the 4 rules. If it meets one of the 4 rules, it's a parallelogram. If it doesn't, it's not. This is your assignment for today, or your practice. Make sure that's done before you check focus for your homework.